Number 6, the graph of f prime is shown for which of the following values of x is f of x concave down, right? I know concave down means that my second derivative is negative. Okay, so to determine my second derivative, I want to do an f double prime chart. Okay, right now I'm at f prime. So to get from f prime to f double prime, I'm going down a level. So I'm going to be looking at the slopes. So I notice that the slopes are going down until I get to 1. So f double prime will be negative. And then the slopes are going up from 1 all the way till I get to 4. So my f double prime will be positive. And then after 4, my slopes are going down again. So my f double prime would be negative. Okay, so I would like to know where is f double prime negative. So I'll just kind of look at these at x equals 1/2. X equals 1/2 is right here, and that would work. So I think we found our answer, but let's just check the other ones. X equals 3/2 is like 1.5, which is right here. And notice that's concave up right there, so that doesn't work. C at x equals 2, 2 is right here. It's concave up there, so nope, that one doesn't work. X equals 5.5 would be 2.5, which would be right about there. And again, positive, nope. And x equals 3 is still in that range, and it still is also concave up there. So A is for sure my choice. Okay, 7. The graph of f prime is shown on the interval 0 to 6. For what value of x does f of x achieve its absolute maximum? Okay, if you have an absolute maximum, we are going to, our process is going to be to find the critical numbers, or we'll find the derivative. So find f prime, and then we'll find the critical numbers. And then we will plug the critical numbers and the endpoints into f. So we want to find f for each of those, and then we'll find out where we have the biggest, because this is a maximum this time, where do we have the biggest value. So let's give this a try here. So first thing that I want to do is actually find the derivative, and the derivative is there. If I want to find, so we're good. We found 1, good. Okay, 2, find the critical numbers. The critical numbers would be where the derivative equals 0. So I notice at actually 0, 2, and 6. So we'll get x equals 0, 2, and 6. And now what I need to do, I need to find f of 0, f of 2, and f of 6. Alrighty, so, and notice that did include the endpoint, so I'm all set. I don't need to do any extras. Okay, right now I am at f prime, and I notice there's no equation or anything to plug in these values to get f. From a previous, actually, one of our multiple choice ones from earlier this week, we knew to get from f prime to f when we're given a picture, we're just going to find the area under the curve. Okay, and I notice this one's going to start at 0, so to get f of 0, we're going to find the integral under the curve from 0 to 0 of f prime. So if I look at the area under the curve, of course there's no area from 0 to 0, so my answer will be 0. And then f of 2 will be the integral from 0 to 2 of f prime. And if I look at the area under the curve from 0 to 2, that's really not a figure that I can find out, but I do know that that is a negative value, and I guess that's all I care about for right now. And then from 0 to 6 of f prime, I do notice that to get from when I go the area under the curve from 0 to 6, it's this whole thing, the area above the x-axis is greater than the area below, so I do know that this is going to be a positive value. So if it's asking me for an absolute maximum, I know that my answer is going to have to occur at x equals 6 because all of the others are not as big because this is a positive value and this is a negative and at 0. So at x equals 6 would be my answer. Okay, next problem, evaluate the integral of e to the x over e to the x plus 4. Okay, I remember if we have more than one e in the problem, we're going to let u be the chunk, and in this case, we're going to let u be the denominator, so we'll let u equal e to the x plus 4. And then du, the derivative of e to the x is just e to the x dx. I notice that I have that, so I'm all set up. So when I go to set this problem up, this e to the dx is du, and then u is on the bottom, and I know that the integral of du over u is equal to the natural log of the absolute value of u. And so then I have the natural log of the absolute value of e to the x plus 4. plus c, of course. And I notice that that's not one of the choices because none of these have absolute values in them. And that's just because e to the x plus 4 can never be negative anyway, so we don't need them. So the choice I am going to pick is e. Okay, number 9, evaluate the integral from 0 to 1 of 2 over the square root of 4 minus x squared. All right, I noticed just from being familiar with the problem that this is the setup for arc sine, and I'll just kind of remind you of the setup for arc sine. It was a squared minus u squared. If you have something like that, please remember that it's equal to arc sine u over a plus c. So notice it is set up similar. We just need to take care of things. First of all, we do not need that 2 right there, so I'm just going to put the 2 on the outside. We can always pull a constant outside. All right, so I need to identify my a would be 2, because notice this is a squared, and then my u would be x, and then du is 1 dx. So I definitely have all of the parts where they need to be. So keeping in mind that I have a 2 outside, I'm just going to put the 2 outside, and then the formula is arc sine u over a, so x over 2, and then I don't need to put plus c in this one because I'm evaluating it at 0 and at 1. And so notice now I have 2 arc sine 1/2 minus 2 arc sine of 0. I know that the arc sine of 0 is definitely 0. And then on this one, again, notice how many times we have to refer to the unit circle, so hopefully we know that. The arc sine of 1/2, I have my fingers out in front of me here. I'm looking for at what value does my answer equal 1/2? And I have my ring finger down right now because 1/2 is below that, and so that occurs at pi over 6. Or however you want to know the unit circle is totally fine. So 2 times pi over 6 is equal to pi over 3. So the choice I'm going to pick is option B. All right, find the limit analytically, which just means without a calculator. We want to find the limit as x approaches 25. So the first thing that we want to do is just try to plug in 25. So I get the square root of 25 minus 5 over 25 minus 25. That gives me 5 minus 5 over 0, and that gives me 0 over 0. That does not mean the limit does not exist. That just means I can't do it that way. I need to find another choice. I do notice that if I have a square root, we did something earlier in the year, which was multiplying by the conjugate. So that's exactly what I'm going to do. I'm going to rewrite my problem. And then the conjugate of square root of x minus 5 is square root of x plus 5. And I'll multiply the top and the bottom by that. Up top, I'm going to FOIL. And when I do that, I'm going to get x minus 25. And then over, I'm going to do nothing to the denominator. I'm just going to write both parts together. Okay, and then I notice that I can cancel my x minus 25s. When I do that, I'm going to be left with 1 over the square root of x plus 5. You'll notice none of the answers look like that, and that's just because we did that so that I would be able to plug in 25. So now I'm going to plug in 25 for my x. I'll get 1 over 5 plus 5, which is equal to 1/10, which is option B. And there we've got it.